Hi, I'm Rogério Esposito, one of the authors of this book. Some people have just asked me how come that general flow equation of the reservoir just collapses to Ji, the diffusive flux, right, equal to zero. Well, there are some premises, some hypotheses you have to assume, right, to write the equation just like that. First one is that you have a 1D system, right? The flow is only to one direction. This direction is the depth, the z-axis. Okay. Well, second, you have a thermal gradient, but just in that direction too. And finally, you have to get a no-flow boundary condition. The no-flow boundary condition, the boundary is Ji equal to zero, right? This is very important for you in order for you to write that equation in that form. Okay, well, I think the whole derivation is here on page 114. Page 114, item 4.3, formulation of classical problems. Okay, take a read at that. But let's see the equation and see what can be done. Come on, come with me. Well, this is the general flow equation of the reservoir, okay? And if you are at steady state, you can say that this term here, you can say that this term here will be zero. And if you have a 1D system, you can say that convection is zero too. I mean, the Darcy velocity is zero because if you have a 1D system, if one component just leave one region to go to the other one, it's impossible to return by convection because there's only one direction. It cannot move to this curve here to get back. There's only one way to go. Okay? And the boundary conditions, the no-flow boundary conditions are very important too. At the boundaries, Ji must be zero. Right? This is very important because the remaining term of the equation is this one. And we may rewrite it as, well, phi, the divergent of Ji plus Ji gradient of phi equal to zero, right? So in the 1D system, this means that, well, d z, well, sorry for my letter here, it's awful, right? Of Ji is zero. Okay, and why is that? Because suppose that if you have Ji equal to zero at the boundaries, right? Because of this condition here, okay, it must be constant and it must be zero elsewhere, right? Everywhere the diffusive flux is zero. And if it's zero everywhere, so this term here goes to zero too, right? Everything is zero in this equation because of Ji equal to zero, because of no flow boundary conditions and the derivative of the flux throughout the z-axis. Okay, well, I think this explains your doubts. And well, this was a very, very important question. Okay, and well, if you want to know more about compositional grading, well, take the book, take a read at it, okay, and send more questions. I'll be happy to answer them. Thank you.